Hey guys, BuildZoid here, and today we're finally going to be taking a look at the Z390 Aorus Ultra motherboard. So then, before we get into the details of this VRM, which you actually get also on the, this VRM is also present on the Pro board and the Elite board, same VRM on those two. Before we get into the details of the VRM, let's just go over some of the other stuff on this motherboard. There's not that much because this one's like a toned down master with a replaced VRM and that kind of thing. But anyway, let's get right into it. Starting off with the feel good about yourself 4-pin power connector. You don't need this unless you're somehow getting the CPU to pull more than 400 watts. Which I wish you good luck with, because in my testing at around 300 watts power consumption, these things are completely, like, a 9900K is very, very, well, it's not 300 watts CPU power consumption, it's 300 watts into the 8-pin. The CPU is very, very hard to cool. But I guess if you're like on, if you have a delidded CPU with like liquid metal and then more liquid metal on top of the IHS, yes, that actually helps. Once you're throwing enough heat once you're pushing enough heat, it actually makes sense to replace your IHS thermal paste with liquid metal. But anyway, if you are running or you're running like direct die or something where you actually have ridiculous, like really good CPU cooling, then it might make sense for you to actually plug in the extra 4-pin. But unless you're modifying the 9900K like that, you're going to be fine just on the single 8-pin. Seriously, like you don't need more power than that. So yeah, this is basically if you're not going to be like modding your 9900K's IHS in some way, you may as well just ignore the extra 4-pin over there. Now then, for the memory situation on this motherboard, it is a 4-DIMM, of course, and Gigabyte's still using T topology on this board as well as the master, so that doesn't change between those, well, between these. So this is on T topology, which basically means the distance from the DIMM slots to the CPU is equal for both DIMM slots, because you have a trace layout that looks something like that, and that's your T right there. And the benefits of this are you have better support for 4x8 memory setups than you have, well, it's not so much it's better support for 4x8, it's just like, well, there's another layout that you can use that has worse support for 4x8. Though ultimately 2x8 is still going to clock higher just because it puts less load on the memory controller. T topology is really optimized for 4-DIMM configurations. So if you wanted to run 32 gigs of RAM on this motherboard, you should probably go for a 4x8 setup rather than a 2x16, because both are dual rank either way. And with 4x8, at least looking at G-Skill's products, it looks like the 2x16 sticks seem to have something like the PCBs don't seem to be keeping up with the rank count on those sticks, because they don't have anything validated for as high clock speeds and low timings as they have for 4x8. So yeah, that's worth noting. So this board is on T topology, and it is a 6-layer PCB. So this is basically the exact same memory setup and memory overclocking performance that you would get on the Z390 Aorus master board. So yeah, that's something this board kind of just takes from the master. You do also have a postcode in the worst possible position, because this is where it gets covered up by PCIe cards the most. Well, I guess if they put it here, it would be worse, but anyway, this is, as far as I'm concerned, not an ideal place to put your postcode, and there's a whole lot of empty space right there. Like, seriously, it could have been there. But anyway, you do have the postcode. It does have dual BIOS. One of those BIOS chips is actually socketed, as you can clearly see right there, so that's pretty neat. And you have a clear CMOS jumper right here. There's no other, there's no buttons anywhere on this motherboard. So that's a little bit unfortunate, but you do still, at least have the postcode, so that's nice. And you have the dual BIOS. It is worth noting that Gigabyte's dual BIOS is a bit, well, it makes memory overclocking a bit tedious, just because it has a tendency to switch BIOSes whenever you fail to post too many times in a row, which gets really annoying because your BIOS profiles are tied to BIOS chips. So if we call this BIOS 1 and this BIOS 2, and you have a profile P1 on BIOS 1, well, when the board decides to switch to BIOS 2, you can't get to your profile. So you need to make a new profile on chip 2 that would be the same as P1. Or the better solution to this is to just save your BIOS profiles to a SSD, like save them either to a hard drive or a USB stick or a SSD. You can also save them to an SSD, but I'd generally recommend you just save them onto a USB stick, because then it's going to be easier to find them as well. So that's kind of that. But yeah, with dual BIOS Gigabyte boards, you kind of don't want to be saving profiles onto the board, because you're going to lose them every time the board decides to switch BIOSes. And it's not like you lose them, because if you get back from the BIOS 2 back to BIOS 1, then that profile is still there. It's just a pain, right? Like getting back from 2 to 1, because unlike the master, this motherboard doesn't have the switches for controlling which BIOS you're on. So on the master, you actually have a switch that puts the board in single BIOS mode, and then you can manually select which BIOS you're on. This board doesn't have that, so you're just kind of at the mercy of the automatic dual BIOS functionality, and it's not fun to deal with that. So yeah, that pretty much covers the non-VRM stuff on this motherboard. There's not really much of that, so let's get into the VRM. The VCore VRM is a 12 phase, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 phases, and this power stage is actually going to this inductor, which is kind of interesting how that's laid out. And then you have +1 for the iGPU power over there, so that's iGPU and VCore for the rest. Obviously, you can't actually buy a 12-phase voltage controller, and this chip is no different. This is an ISL, and I'm going to run out of space if I do that. So that is an ISL 69138. This chip is also rather popular on high-end X299 motherboards, like the EVGA X299 Dark and the X299 OC formula from ASRock. So it's a good chip, but it doesn't really support a ton of phases. It doesn't go quite, I don't think it goes quite as high as the International Rectifier 35201 in total phase count, but that doesn't really matter here. It's running in 6+1 phase configuration, and that 6 is going into a set of ISL 6617 doublers, and these are current balancing doublers. So basically what that means is these are quite complicated and quite expensive as a result, and rather smart, because basically the ISL 6617, which we can't see them, they're on the back of the board here, but basically you have your ISL, well, let's not do it on those. Man, this layout is annoying to deal with. So you're gonna have something like that, right? That's your two phases over here. So basically the idea with the 6617 is that, let's say the chip's right here, right? Which I think it roughly is right there, or might be more here. Either way, doesn't matter. Basically, this chip monitors the current through both of the power stages, and when it sees a current imbalance between them, so let's say this one is pushing 50 and this one's pushing 40 amps, then the ISL 6617 will actually do a PWM pulse extension for the power stage pushing less power. And the reason why you want this functionality in your doubler is because it further improves your VRM efficiency by making sure that your load is evenly spread through all power stages, regardless of what's actually going on with the output of the VRM. So the doubler can actually maintain really good efficiency here. Another cool feature with the 6617s is you can actually put them into bypass mode, where the VRM can, I don't think there's any motherboard that actually makes use of that, but you can take the 6617 and basically, instead of running them in doubling mode, you can just make them pass through, so they stop actually doing anything to the PWM signal, and the VRM would quickly go from being a 12 phase to a 6, because it would just run both power stages at the same time. So yeah, that's a pretty neat chip that Gigabyte is using here, and yeah, so that's the control scheme, and this is basically as close to a real 12 phase as you can get, right? Because that's current balancing across all 12 phases, with interleaving with everything. The only real downside to using the doublers is that they do put a little bit of delay onto the PWM signals, going from the 69138 to the actual power stages. So yeah, these are great. These are pretty awesome doublers. They are also rather expensive as a result. Anyway, Let's talk about the actual power stages now. So the power stages Gigabyte is using here are Vishay Semiconductor SIC 634s, and these are 50 amp direct driver MOS modules, so DR MOS, which is basically one of the dumbest version. Like, this is like the most basic type of power stage you can get your hands on. They're not very smart, but they do the job, right? So they handle 50 amps. And interestingly enough, on paper, this VRM here, because of the use of these 50 amp DR MOS modules, it actually works out to be more efficient than the VRM on the Z390 Aorus Master. However, Gigabyte has done internal testing on this about which of these VRMs actually runs cooler in practice, where they took both motherboards, so both the Ultra and the Master board. They took the VRM heatsinks off, so, you know, eliminating the variable of the fact that the Master has a different VRM heatsink design than the Ultra does. So they took the VRM heatsinks off, and they ran both of the boards, and ultimately this VRM runs about 1.5 degrees hotter than the other one, which is just like, okay, and it may have something to do with the layout. Like, you do have the fact that, like, the Master basically has 6 power stages up here and then 6 power stages over here, whereas you can see that this is 5 up here and 7 down here, so you kind of get more of a hotspot on this one, because there's 3 power stages above it and 3 power stages below it, instead of, you know, having like 2 in the middle and then 2 and then 2 and then this one not being there and being over here. But ultimately, this VRM does run ever so slightly hotter, which is why this VRM ends up being on the Ultra and the Pro and the Elite motherboard. Also because these SIC 634 50 amp power stages are ridiculously cheap, compared to like the IR 3553s, which is kind of interesting, and it probably has something to do with the 3553s being much smarter than these chips are. But yeah, this VRM tends to run a little bit hotter, but on paper, it's more efficient. And I'm not sure how that actually works, because in theory, if it's more producing less heat, it should always run cooler, unless it has a thermal, unless there's some kind of thermal dissipation issue. Like, this has harder time dumping heat into the ambient air than the other VRM, which seems really unlikely because these power stages actually use a larger package than the 3553s. But yeah, ultimately this VRM apparently in Gigabyte's own testing runs hotter, and I saw the testing. I don't see any mistakes in it. So yeah, the only thing at this point that I can think of that would possibly make this one run a little bit hotter is the fact that they have 7 power stages here instead of 6. But even then, it's just like, oh well. Nonetheless, you end up in a situation where this is a great VRM. It's just that the efficiency figures imply that it should be better than it really is. So what are the efficiency figures? Well, for a 500 kilohertz switching frequency on the actual power stages themselves, and either 1 volt or 1.3 volt, 1.35 volts, no, 1.3. Actually, give me a second. I'm taking up too much space with this. 500 kilohertz, 1 volt or 1.3 volts. You're going to be looking at, so that's the switching frequency. Drive voltage for these is 5 volts, and that's because these run on 4.5 to 5.5 volts, so it doesn't even make sense to try overvolt them or anything. These run only on 5 volts. Unlike the 3553s, which have the entire datasheet spec'd in 7 volts, and then a recommendation from the International Rectifier to not run them at that, which is just like, I mean, why would you write your datasheet at a voltage that ultimately doesn't work? I will never understand, but anyway, yeah, so these are the operating parameters here, and 150 amps output, which is like, which is actually really easy to hit on a 9900K. That's not a problem. 150 amps, theoretically, this VRM will produce about 12 watts of heat at 1 volt, and about 13.2 watts of heat. That's not 13, that's 13.2 watts of heat at 1.3 volts. Now, going up to 200 amps, which is pretty much where a 9900K is going to max out in terms of power consumption if you have a lot of cooling on it. You're going to be looking at something like 16.5 watts of heat at 1 volt, and about 18.5 watts of heat at 1.3 volts. So again, like, ultimately this board is one of the most efficient VRMs on Z390, which is kind of crazy that, you know, Gigabyte also uses it down onto the Pro and the Elite. It is worth noting that the Pro and the Elite use a 4-layer PCB, so that VRM will actually inherently run a bit hotter just because the PCB has less worse thermal dissipation properties, and also those boards have worse memory overclocking support because of the lower layer count. But yeah, you still get this VRM, which is really, really great because it's an awesome little 12-phase here. Well, little doesn't really fit this, but it is a very nice 12-phase. So going up to 250 amps, again, the efficiency on this thing is absolutely killer. It might also be a difference in how the spec sheets are spec'd, but I spent a lot of time trying to like account for everything, and I couldn't find anything that was different. So 22 watts versus 25 watts for 1.3 volts. And at this point, we're talking like sub-ambient cooling. 300 amps output, you're going to be looking at about 29 watts of heat versus 32 watts of heat. And then going up to 350 amps output, it's going to be 39 watts at 1 volt and 43 watts at 1.3 volts. And finally, 400 amps output, it's going to produce 52 watts of heat at 1 volt and 57 at 1.3 volts. So, yeah, this VRM right here is very, very efficient, at least on paper. Apparently, it does somehow manage to run ever so slightly hotter, but nonetheless, it's not like if you basically want the same overclocking capabilities as the master motherboard, and you don't, because actually I'm not sure that the ISL 69138 based motherboards have all of the VRM controls that the international rectifier boards have. Like, they all have load line calibration, all of that, but the international rectifier boards have things like switching frequency settings and, what else was there? Various VRM protections and phase mode, and I can't remember if I saw the same thing in the BIOS for the Pro that I have, because I actually have the Pro. So, yeah, not sure if there's going to be like a difference in how much you can mess around with your VRM settings, but ultimately this should not be that different from the Master in terms of overclocking capability. Yeah, basically you get a really, really solid VRM for a little bit cheaper. You maintain the same memory overclocking capabilities. And what's kind of crazy is actually this motherboard still has the full linear voltage regulator loadout for extreme overclocking. So you can see 3 of them here, and then there's a couple more of them hiding in this, like 2 more of them hiding under the heatsink here. So that gives you your things like VCC PLL, PLL_OC, which this voltage right here affects your CPU temperature sensors. So don't mess with it unless you're going on liquid nitrogen. Like, don't set it below, like this voltage is supposed to be equal to 1.2 volts or higher. Okay, if you set it below that, your temperature readings are just going to be completely wrong. And if you set it really high, your temperature readings are again going to be completely wrong. They're going to be way too high. But 1.2 volts is where it's spec'd at by Intel. Gigabyte likes to run it at 1.25. I'm not sure why they decided to do that, but they did. So that's kind of that. And then there's things like VCC VTT, VCC ST, which I think is VCC substained. And like there's a bunch of, basically there's 5 voltages that are necessary for extreme overclocking. And this motherboard has all of those because it keeps that section of the VRM also off of the master. And like the master, it's also hiding the VCCIO and VCCSA phases down, which I think SA is the first one in that. So there's one phase VCCSA and then VCCIO under the M.2 nameplate. That does not look like a heatsink. It's a plate and it's got a name on it, so we'll call it an M.2 nameplate. It may or may not have some thermal benefits for the M.2 under it, but I doubt it. But yeah, you have VCCSA, VCCIO, single phase under there. Those are again on the reduced package size 4C06N MOSFETs. And Gigabyte's using this power, these MOSFETs for VCCSA and VCCIO on like their entire lineup of the ATX motherboards, and this works fine. Like, it really no problem because neither of these rails really pulls that much current that you'd need something better than that. So I have no complaints for that. They're just hiding under there. And for memory power, we have the standard Gigabyte, 1 high side, 2 low side MOSFETs. All of these are 4C06Ns, 4C06Ns, and it's a single phase like that. I assume the voltage controller is that chip over there, which is probably a Richtech 88 something, and I can't remember the rest of that, which is going to be the same controller as what they use for over here. I'm starting to think this might have been a controller and not an LDO. That might be a controller, not the LDO, and there's 3 LDOs hiding under here. Anyway, the board does have all of those things, just because they did keep like a very large chunk of the upper portion of the motherboard off of the master. So yeah, it's kind of an interesting motherboard. It does kind of a little bit of everything. You get the 12 plus 1 phase VRM off of the cheaper boards, but this is still a really like good 12 phase. Just if you want to do like a direct comparison, like against say the Asus Maximus 11 lineup, Asus uses Asus uses an SiC 639 power stage, which is also a 50 amp part, except they have 8 of them instead of, 12. And Asus runs them in 4-phase mode, whereas Gigabyte's running them in 12-phase mode. So yeah, ultimately, this is a better VRM as far as I'm concerned. And really, I think this is probably the best VRM for the entire price range that this VRM is used on. Like, there's no board that even comes close to it, because nobody does that. Like, nobody else has as many phases, and nobody else is using like 50 amp power stages in this quantity at these price points. So yeah, I really, really like the VRM. The memory overclocking support, I mean, my experience with the Master has so far been kind of terrible. And by terrible, I mean, I can't get my 33 megahertz memory kit above 4000 megahertz. And I've talked to Gigabyte about this, and they basically told me if you had a kit that has an XMP rated above 4000, it'll work, because those set some settings that aren't like directly accessible in the BIOS. And they also told me they're working on improving memory overclocking support in general, but I'm not sure when we're gonna see that. Actually, it's not out yet. So right now, it's like, right now with the Gigabyte boards is basically, if you want something to run on the Elite, I mean on the Ultra or the Master, because the Elite boards are even like the Elite and the Pro on that 4-layer PCB, they clock memory even worse. But with the Ultra and the Master, you're basically going to want to look for memory kits that are rated at, that are on the QVL of the motherboard. Because if they're not on the QVL, they're very unlikely to work above 4000 megahertz, just because the board kind of has issues with that right now. And apparently they are working on fixing that. I don't know when it'll be ready. And yeah, but like, since technically if you use a QVL kit, it'll work, I'm not seeing such a huge issue with that. Though I would like to point out that I think Gigabyte advertises this motherboard as having some crazy 44,400 or something like that memory frequency support, and that there's kits rated at that are on the QVL. I would not actually recommend buying kits rated at what the motherboard is advertised at, so based on the fact that a lot of the time when motherboards are spec'd at doing like you see a lot of motherboards which are like, oh yeah, this totally supports 4.8 gigahertz memory clock, and the thing they're not telling you is you need like a top 1% CPU with a really good memory controller. By top 1%, I mean top 1% memory controller, not core. We're not talking about the core here, just the memory controller. So you need a really good memory controller for really high frequency memory XMP profiles to work. And if you have a motherboard advertising some crazy XMP profile speed, there's a good chance they tested that with a CPU that you're unlikely to find. So, well, unlikely to randomly get. So I wouldn't buy, like on a motherboard that's advertised as 4400, I would realistically expect it to do 4000 to 4200. And a motherboard that's advertised to do 4600, I would realistically expect it to do 4200 to 4400. So just kind of keep that in mind. And that's even if you're running XMP kits, right? Like, just because the CPU does actually play a role, it's not just about the motherboard in that scenario. So yeah, that is the Z390 Aorus Ultra. It's really well rounded in my opinion, and probably the best value motherboard from Gigabyte. Because it keeps a lot of the good stuff from the... Well, I miss the BIOS switches. I really want the BIOS switches, but it keeps most of the stuff you really need off of the master. And at the same time, you do still get a really, really solid VRM. They do change the heat sinks out, but it's not going to make such a huge difference. Like, this VRM is kind of... this VRM should have no problem handling a 9900K. So the heatsink doesn't really need to do a great job. And yeah, that is it for the video. So thank you for watching. Like, share, subscribe. Leave any comments, questions, suggestions down in the comment section below. Thanks to Gigabyte for actually providing the picture of the motherboard. And what else is there? Right, if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon and t-shirts. You can find links to both down in the description below. And those help out immensely with running the channel. So yeah, that is it for the video. And I'm going to go hit the stop button. Where is it? There it is.